In this video, we want to discuss about series and sequence. Series and sequence is a very interesting topic, but if you don't understand it, it will give you a very difficult time to solve some questions about it. So welcome to this video. Kindly subscribe, share, and kindly subscribe, like, and share to other students who also need such help. Welcome. So in series and sequence can be classified into two categories. The two categories are geometric progression. The first one, geometric progression. And the second one, arithmetic progression. So these are the classification of series and sequence. In any question, they may test on geometric progression or arithmetic progression. They are almost similar, but differ in a very little difference. They just have a very little difference about the common difference and the common ratio. That's what differentiates them. But all the rest remains the same. So we shall start with geometric progression. Let's begin with geometric progression. In geometric progression, you have to consider three very important letters. These letters are, you can say, let n be the number of terms. Then let r be the common difference. And finally, let a be the first term. Now, let's explain what do you mean with these three letters, N, R, and A. So we can have our series, or we can have an example of our sequence, like 2, 4, 8, 16, 32, 64, 128. And the others probably up to the 20th term. So let's explain our letters. N is the number of terms. The number of terms we can name 1, 2, 3, 4, 5, 6, 7. So our n is equal to 7. The number of terms, our n is equal to 7. It does not mean it is the term in the sequence, but just the number of terms if you count from 1 to the maximum. R be the common ratio. R is the common ratio. And how can you get the common ratio? It is the first term, it's the second term divided by the first term. So let's try. This 4 divided by 2. That one is equal to 2. Then 8 divided by 4. That one is equal to 2. Then 16 divided by 8. That is equal to 2. So 2 is our common ratio. It's the second term divided by the first term. What you get is the common ratio. The quotient is the common ratio. So first term, A. is the term which appear first, the figure or the number which appear first. So our first term here is 2, because 2 become first before all any other number. So that is our N, R, and A. So let's begin to know the formulas applies in geometric progression. So the formulas are, the first term is A. The second term, how can you get the second term if you had the first term and you have the common ratio? So the second term, which is 4, it will be 2 if you multiply by the common ratio. The first term, which is A is equal to 2, multiply by the common ratio, which is equal to multiply by 2. So that one will give you 4. So first term is A. The second term is A multiplied by R. So that one gives you the second term. Third term now will still be A multiplied by R multiplied by R. Again, fourth term will be A multiplied by R multiplied by R multiplied by R. So in short, our first term is equal to A, second term is equal to AR, third term is equal to AR squared, and fourth term is equal to AR cubed, and as it's gone on as follows, as up to the maximum. So what you need to understand is the first term, how you can get the first term, second term, how can you get the second term, third term, how can you get the third term, fourth term, how can you get the fourth term. And because of this one, you can deal with a very big figures or a very big number of terms. Let's say the 20th term. So doing it like this in up to the 20th term is very difficult. So we have the specific formula to get the number of terms. So the formula we have to get the number of terms, this one will give you, is the first term A. This first term you multiply by the common ratio. The common ratio, now you inquire n raised to power n. In this raised to power n, you subtract 1. So that is the formula to get the number of terms. Let's pick, for example, you want to get the 20th term. Like in our sequence, we don't have the 20th term. So what is the 20th term? So you shall apply our formula. By applying the formula, you will say our A is 2. A is 2. Apply the formula. A is 2. You multiply by R times R, which is 2. Our R here is 2. Raised to power n. Our n is 20 minus 1. So that one will give you 2 times 2 raised to power 19. If you calculate this one, 2 times 2, that is 4. 4 raised to power 19, you will get an answer of 1048, 576. So our 20th term is 1048, 576. So that's how you can use the formula to get the term on the 20th term. So this one is the 20th term in the series. So another one, which is also very important, is the sum. The sum of the term. The sum of the nth term. So how can you get the sum of the nth term? The sum of the nth term in a geometric progression is given by, for example, if you take our progression here, the sum of n is equal to, what is our n? 1, 2, 3, 4, 5, 6, 7. 7. So the sum of nth term is equal to, you can say, 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. This total give you 254. But how can you get it without manual addition? So there is a formula to get the sum of the nth term in a geometric progression. This sum of the nth term is given by a formula. Sum of nth term is equal to a into bracket r raised to power n minus 1. This one you divide by r minus 1. This one is this formula you can get is an SMP table or logarithm table. If you look at the back pages of the logarithm table, you will get this formula. So this one is applied where r is greater than 1. So in our case here, our common ratio is 2, which means that our common ratio is greater than 1. So it's very easy to apply this formula. So let's see if we shall get the same answer. So in the same way, we can just apply the formula and get the sum. Our sum of number of terms, 7 terms, now n becomes 7, is equal to a, our a is 2, into bracket r, our r is 2, raised to power n, our n is 7, minus 1. This one you divide by r, which is 2, minus 1. So if you take this one, our 2 raised to power n minus 1, you will get, let's take 2 raised to power 7 will give you 128. So 128, this 128 minus 1 will give you 127. 127 now you multiply by 2. That one gives you 254. 254 divided by 1, and that is equal to 254. So our answer remains the same, 254, which is the same as 254 when you add manually. So apply this formula where your common ratio r is greater than 1. But what about when r is less than 1? You can have a common ratio where r perhaps is 2/3. R is 2/3. So what about if you have r as 2/3? This one you can't apply this formula of a, r raised to power n minus 1 divided by r minus 1. This one is impossible. But now we shall provide another formula. The other formula you should use where r is equal to 2/3 is sum of n is equal to a into bracket. Now you start with 1 minus r raised to power n, all divided by 1 minus r. Use this formula when dealing with the sum of geometric progression where common ratio is less than 1. So common ratio R is less than 1. So having done with geometric progression, let's now see arithmetic progression. For arithmetic progression, everything just remain the same. Let A be the first term, and D be the common difference, and N remains number of terms. Let's take an example of arithmetic sequence: 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30 up to the 20th. So this is our sequence. How can you know the first term? Our first term remained is equal to 3, this one. Second, common difference. Common difference now is the first term, the second term minus the first term. So D is equal, D in small letter, D in small letter is equal to 6 minus 3. That one give us 3. Or 9 minus 6. That one give us 3. Sorry, this one is 3. This one give us also 3. Or 12 minus 9. That one give us 3. So that one remains the common difference. The number of terms N still remains the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and onwards up to the 20th term. So our number of terms remains 10. So let's now know how to apply these letters in terms of equation. So in terms of equation, our A remains the first term. But now our second term is A. This A, let's take 3 plus the common difference, which is 3. 3 will give us the second term, which is 6. So if you take the first term, which is 3, plus the common difference, first term 3 plus the common difference, which is 3, will give us the second term. At the same time, if you take the second term 6 plus the common difference 3, will give us 9. So first term remains A, second term is A plus D, and third term remains A plus D plus D. Fourth term remains A plus D plus D plus D. So in short, we say first term is A, second term is A plus D, third term is A plus 2D, fourth term is A plus 3D. So why always 3D? Because the first one is being held by the first term. And that's where now the formula comes from. That the number of terms, in order to predict the number of terms or the 20th term in a sequence, is that we shall take the first term A into bracket N plus A plus into bracket N minus 1, you multiply by the common difference. So this is the formula to get the nth term of a sequence. So take example as the nth term of the 20th term of our sequence. The 20th term will be, now our first term is equal to A. first term is equal to A plus into bracket our n now is 20, n is equal to 20, so our n is 20 minus 1, then you multiply by the common difference, which is 3. So A plus this one is 19 multiply by 3. So that one will be 3 plus this one times this one. If you add them, 19 multiplied by 3, and that will give you 171. If you work out this one, will give you 171. And that is the 20th term of the arithmetic progression. Let's go to the last sample, which is now the sum of the nth term. The sum of the nth term. The sum of the nth term now will become Sn is equal to n, that our n, divided by 2 into bracket 2a plus n minus 1, you multiply by the common difference. So this one give you the sum. And let's take our example, the sum of the 20th term of this sequence. That one will be S20 is equal to 20 over 2 into bracket 2 multiplied by A, which is 3, plus n is 20 minus 1 multiplied by the common difference. The common difference is 3. So when you calculate this one is 10 into 6 plus 19 multiplied by 3. That one will be 10 times, this one will be 10 into bracket 6 plus 57, and that one gives us 10 into bracket 57 plus 6 will give us 63, and the sum now become, the sum of 20th term is equal to 630. 630. So for our case here, in our case here, the 20th term is not this one. Sorry for that one. Our 20th term is 3 plus into bracket 19 multiplied by 3. 19 times 3 is equal to 57. 57 plus 3, that one is equal to 60. So our 20th term is equal to 60. 60, not 171 but 60. Thank you. Now let's meet in the next lesson for next examples. Thanks.